Okay, let's start here. Problem 24. Oh, you didn't do it, right?
Yes.
Okay, suppose it's not so hard. If you feel difficult, go back to check the core concept, right? You see here is the core concept. A exponent is m over n, then is equal to a nth root, then m's power, right?
Yeah.
Now, can you find this to do it? Let me give you whiteboard. Yeah, you see, you just found an example here. Oh, come on. Yeah, yesterday we talked about not cubic root, right? Yeah, please decide what's the cube root for 125.
Cube.
Yeah, I suppose you mean 5 cube equal to this, right?
Yeah.
Then what's the value of this?
5.
Yeah,
That would be 5, 2.
5 square. Okay, then what's the reason that you cannot get this done? You see, we just go back to here, to the core concept,
Yeah.
to an example, right?
Mm-hmm.
Okay, yeah, please screenshot.
Okay.
Problem 30, okay. Error analysis. Let's say, so you mentioned this is your final answer?
Probably not correct. So.
Yeah, so I mean, think about how to do this correctly. Yeah, just do this. Yeah, so this completely matches the first step, right? Then what's next? That means that decide this, right? Please decide this. Hold on. Why we suddenly go to this? Negative 16.
Trying to find.
Negative 6, sorry.
I'm trying to find this. So.
Okay, so you just tell what this should be. Yeah, could you erase here? Could you erase here? Oh. Yeah, decide this. Okay, so let's go to the core concept. Yeah, the core concept is here. You say it's the which case? Which case is it?
Is less than 0.
Yeah, if n is even and a less than 0, then what happens?
There is no real nth root.
Yeah, that's it. Or we call it undefined, right?
Okay.
Yeah. That means that you cannot find a number whose fourth power equals to negative 81, right? Okay, so we are at here, right? Yeah, so I also tell you the method. If you find the problem, you cannot do it. How you can solve it? Go back to the concept, the definition, the law or theorem. Check it, then see some examples and try to understand it. Then go back to this problem. Yeah, anyway. So here means undefined, right? So this is not good. So okay, please screenshot.
Okay.
36. Excuse me. The volume of a cube-shaped box is 27 fifths power, right? 27 fifths power. So why you have this? Oh, hold. Why here go to 50?
I might have
It's strange.
mistyped, I think.
You say you just type couple of characters. You have to always ask, oh, are they correct? Okay, anyway, so this doesn't make sense, right? Now, could you think about it? Think about it. Here is the fifth power. Okay, then how to get the length, or we call side length? It's the same thing. Oh yeah, keep going. The first step is very good. Or even you can write as this. Yeah, let me start from here. Means side length, I call it S, equal to cube root of volume, right? Then equal to this. Yeah, then keep going. How you can do it?
Find this first.
Yeah, do you wanna say something? For example, the core concept. Do you need to go back to C?
Yeah.
Okay. Okay, I suppose you see here, right? Yeah, I believe what you should use is here. Yeah, if you found this, how you can do it?
Doing that.
Okay, I just suppose cube root means keep this no change. Then write it as 1/3, right?
Okay.
Yeah. You say that's why I circle here, you say.
Okay.
Then keep going. It means 27 5 over 3, right?
Mm-hmm.
Okay, 27 is not a prime. So we can do a prime factorization. Anyway, it means 23 equal to 3 cube, right?
Mm-hmm.
Then keep going. 3 times 5 over 3, you get 3 fifths power. Then this equal to, okay, the unit should be, let's go back to problem. Okay, yeah, it's this problem. Let me circle it again. Yeah, so here the volume is cubic millimeters. So suppose here side is just a millimeter, right? Okay, please screenshot.
Okay.
The cost of organose gas increased from this to over a period of 10 years. What we should do? Use the formula R equal to final over principal. 1 over n power minus 1 to find the annual inflation rate of the nearest to the nearest tenth of a percent. Okay, so actually you do nothing here for this problem. But if you read this, even for me, suppose if you assume I'm new to this formula, then I just found this formula, right?
Mm-hmm.
Uh, or if to be better, even you can go to say example 5, right? Instead of just say I can do nothing. Okay. You say just use this formula. They already tell you the formula. Then we can get R equal to F means final 3.53. P means the beginning value. Then 1 over n. What should be n here?
And should be
We do problem of 42.
10.
Yeah, because 10 year, right? Then minus 1. Of course, we need a calculator for this, right?
Mm-hmm.
Hmm. Do you know how to use a calculator to get final answer? Do you have a calculator in hand?
Yeah, well, I have my phone. So.
Yeah, then yeah, have a try. Do you get the answer?
No, not yet.
Not yet.
I'm going to do this.
Yeah, I just want to know you can make use of calculator to do it. Okay, what I get is 1.0923 minus 1. That means that 0.0923. Here, let you round to nearest tenth of a percent. So it's about 9.2%. Okay, you can just screenshot and do more works on this problem after class.
Okay.
Okay, next. Simplify the expression. Yeah, talk about this. You should use several formula. Yeah, let me try to find the one for you. But at this side. Yeah, let me duplicate one, then move it here. Okay. So,
How can you write and evaluate an nth root of a number?
oh, maybe the formula is on section 6.1. So let's go back to there. Yeah, do you see here?
Yes.
Because here is a product, right? So you need to use same formula like here. If a product's m's power, then it's equal to a's m's power and bm's power. Okay, so let me just show you how to do it. Anyway, we are working on problem 48. So we have x 1/3 times 9's power, y 1/2 times 9's power. Then this we call y square root, right? Yeah, right as rational exponent is 1/2. So anyway, here 1/3 multiply 9, you get 3. Here you get y 9/2 y half. Then together it's y 9/2 plus half. Then finally we get x cubed y fifth power. Yeah, that's the final answer. Please screenshot.
Okay.
Okay, next. Non-negative real number. Determine whether the statement is always true or sometimes true or never true. Justify your. Yeah, so first, when here call it's a non-negative real number, then that means x can be 0, right? Yeah, but I think this is fine. Okay, so you mean it's never true, right?
Yeah.
But how about if x equal to 1? Do you think it's true?
No.
Of course it's true. 1's cube root also equal to 1. 1's cube also equal to 1. Then of course it's true. Right? Yeah, that means it should be sometimes true. Sometimes. Yeah, then let me circle here. Means sometimes. When x equal to 0 or 1. You say if x is 0, it's also true, right? So here I write sometimes. Right? Then final problem. What we should do here? Means evaluate, right? For x equal to, yeah, we talk about problem 60. When x equal to -3, yeah, so this is correct. 0, 8. Okay, this is good. Yeah, please screenshot.
Okay.
Now let's go to next section. Exponential function. Identify and evaluate exponential function. So, could you read this sentence from an exponential from here?
An exponential function is a nonlinear function of the form y is equal to a is not true, so for a constant amount, the dependent variable line is multiplied by a constant factor, which means consecutive y values from a constant ratio. Functions.
Consecutive. Okay, so you're done, right? So here means exponential function is in this kind of form. A is not 0, B not 1. Yeah, let's tell why B, A must be not 0. Because if A is 0, this just go to y equal to 0, right?
Yes.
Yeah. So if y equal to 0, what's the graph for this? Y equal to 0. Yeah, if let you go to draw y equal to 0, can you? Let's try. Let me find the decimals. Where can I find one? Yeah, can you draw the graph of y equal to 0? Or think about if I type in y equal to 0, how decimals can draw it for us? Okay, have you done? It's a point? Yeah, think about if I input y equal to, yeah, if I type in 0, what will happen? What kind of graph will see? Yeah, it's a horizontal line, just the x-axis, right? Okay. Yeah, so it's a linear equation we already learned. It's not an exponential function. That's when a cannot be 0. Now talk about why b cannot be 1. If b equal to 1, then 1x power always equal to 1. So y just equal to a. A is a constant. So it's still a horizontal line, right? It's something we already know. Now talk about why we require b greater than 0. The reason is, yeah, let me just tell you. For example, if b less than 0, -2, then, for example, when here is x equal to half, this is undefined, right?
Mm-hmm.
Remember, it's undefined.
Okay.
Yeah. So that's the reason we don't wanna explore this kind of function or this kind of relation. Now we would explore the case b greater than 0 first. Yeah, if in the future you have a chance, maybe you'll go to explore this kind of relation, right? But it's not the task here for exponential function. Yeah, anyway, this is the requirements for exponential function. Then based on this, we'll see some specific exponential function. Evaluate each function for the given value. Okay, I'll let you do one.
Okay.
Can you do problem 4 for x equal to -2?
Let's see. Y is equal to,
Now x equal to -2.
if x is equal to -2, so it's
Yeah, keep going.
so the
Yeah, how to handle 2 power of -2.
2 to the power.
Yeah, this is key thing you need to know. Remember the formula? Okay, I'll say how you do it.
Okay.
We learned this in section 6.1.
1-2.
No. Okay. See here. A negative n equal to, right?
Mm-hmm.
Okay, find this to do it.
Okay.
Here we don't have a. You see here a is a exact number 2. We don't have any a here, right? A is just generally represent the base. When base here the base is 2, so you just write 2. Okay, so let me get it done. It means 1.5 multiply 1 over 2 square. So it's 1.5 times 1 over 4. That means that it's 8, 3 over 8, right?
Mm-hmm.
Okay, please screenshot.
Okay.
Now let's say graph an exponential function. I'll let you graph it yourself. Yeah. For example, can you do a basic one? Let me move it a little bit. Yeah, please draw the function y equal to 2x power. We know it's a nonlinear function or graph. So you need to find the 0 points, right? So these 0 points you find a curve. And of course, you'd better have the key points. Think about what means key points.
Y is equal to 2x.
So let me ask you, what should be the y-intercept for this function?
The y-intercept
Yeah,
0.
y-intercept is a point. So you should tell this point when x equal to what? The corresponding y is what?
Okay, when x is equal to 2, 2 times 2 is 4.
No, no, no. Y-intercept means when x equal to 0, what happened to y? Yeah, y-intercept means intersect with y-axis. For y-axis, on y-axis, x always equal to 0, right?
Yeah.
Yeah, that's the reason you let x go to 0. Now talk about what's the value for y.
And 1.
Okay, yeah, then mark this point on the graph, on the coordinate system. Okay, good. Then you can find some other point. For example, if x equal to 1, what should be y? If x equal to -1, what should be y? If x equal to 2, what should be y? If x equal to -2, what should be y? Yeah, can you find these 4 points?
Yes. If x is equal to 1,
Mm.
e 2.
Yeah, keep going.
Negative. And if it was 2, then it should be 2 times 2. 4.
Yeah, when x equal to 2 is 4.
2 times 2.
Okay, yeah, just means 1/4, right?
Mm.
Yeah, I know it's hard to mark it. Let me say, yeah, it's about here, right?
Yes.
So if we draw this, then it's a graph, right? Yeah. After you finish this, you can let Desmos draw for you for comparison. For example, y equal to 2x power, right? So you say it's almost the same, right?
Yes.
Or even let me do this. Okay. Yeah, please screenshot this.
Okay.
香港的话，你只需要看它起飞的时间，因为我其实所有的客人那个信息都发给那个娜娜那边了。其实就是香港那一块，我们几乎没有什么操心的，知道吧？因为酒店娜娜那
Then
里，
graph and exponential
我们其
function.
实就是它格里面
Yeah,
多一
here
个，
show you
你就
several way,
放到自己的
several
去，
case. For example,
然后你们就
a
他
greater
听
than
到
0 or a less than
听到
0.
客人出发前，会把客人和娜娜他们一起拉到一个群里来。
B greater
或
than
者
1
上
or
面
B
它就
just between 0 and 1, right? Again, just remember B is not negative. And of course, B is not 0. So B greater than 0 and B don't equal to 1, right? b doesn't equals to 1, or b is not 1. So we break it into two cases. One is b greater than 1. Another is b is between 0 and 1. So in your homework, you should draw more in order to understand it very well. And another is for the basic one, for like what we draw just now, y equal to 2x. This is always greater than 0. Yeah. Yeah, here show how they draw it. And here draw two graphs. One is for 2x power, another is for 4 times 2x power. Right. And keep going. Here is more general. You should use the transformation knowledge from chapter 1 to understand how to get this from the parent function. Let me say that take the parent function. Yeah, they take this as parent function. For example, it's the black graph here, right? Then if x replaced by x minus 3, we move the parent function 3 units right. Then if we plus 2 here, say, then we move it up 2 units. So that's the reason you say it's called 3 units right and 2 units up. Okay. Comparing exponential function. Oh, okay. So they just found this table to draw the line. Then connect this line by a curve, right? You see here, say draw a smooth curve through the points. Yeah, when you go to two problems like problem 7 or problem 8 here, you should have the knowledge of transformation function, right? You go to the previous chapters to find the knowledge about function transformation. Or you can also go back to the videos we recorded in past. Okay. Yeah, problem 7. In order to solve this kind of problem, you can as it mentioned, using exponential function, you can think it as y equal to a bx, right? Or even you can say there is plus c. Yeah, but the minimum, this range is still greater than 0, then suppose the c is 0. Means we didn't really add a number, but don't write it as this. So c equal to 0, then y just equal to a bx. Then use 2 points to decide a and b. Yeah, finally get this. Yeah, it might be kind of hard. Okay, now let's assign some homework.
Okay.
Okay, let me write homework here. Section HW today's date. Okay. Okay, I think that's for today's class.
Okay.